Regarding the asset integrity problems associated with floating assets, how do you go about understanding these problems?
So what we want to do with the wind energy side is set up a floating offshore wind JIP. And that JIP's function is not to solve the problems, it's to ask the right questions. So it would sit down with people that represented different parts of the industry, like the regulators, the people that operate the plant, the people that provide services, all of that stuff. And we would say, okay, what do we think are the main challenges that we're going to face in this industry? And we try and narrow it down to the top 3 or 4, so we don't bite off too much and get indigestion. And then we will say to the industry at large, we've identified these problems. We've also not just identified them in a broad sense, but in a detailed sense. So we'll say, for example, one of the problems is how are we going to keep these systems attached to the seabed in rough weather for 25 years? And that would start sparking some encouragement from the industry to come up with solutions. So that's really what we do. We get the whole group of people together and see what the main challenges are.
And with new technologies and introducing them to the market, is there a specific process you'll undertake?
Yes, obviously we've already discussed the concept of finding out what the problems are. Then we will identify a number of different solutions. Some of them, you know, after a short time, it's going to be a dead duck, so you abandon those. But when you come up with a solution that you think works, then we go through a series of trials and tests. Now, we're fortunate that we have a very comprehensive technical development centre in the UK, in Cumbria, and in other places as well, in Canada, for example, and Australia. But we can test these things out in very large tanks, for example, in huge buildings that we share with an organisation called Forth, and they were originally destined to provide solutions for the nuclear industry. So they're very clever people, and between us we'll make prototypes, we'll test them out, and once we're comfortable that they meet the standard, then we invite people from the regulators and clients to come and have a look, and they also might add good ideas. And when we finish, we'll end up with a machine that we can take to site and try out. That process can take as long as 2 or 3 years. For example, there's a problem in industry which is really coming to bear now, where people used to go into confined spaces like storage tanks to inspect tanks, and they would climb up on ropes, which is fine. I was part of that industry many years ago, but it's risky. So by developing the solution that avoids putting people in these hazardous areas, you take them away from risk, and that's you win everywhere. It's less dangerous, it's less costly, and you get a better result. And people are then retrained to run robots instead of putting themselves in harm's way. So for me, that's a multiple win.
With your technology, EM&I's technology, could you detail like an application of it on an offshore wind farm, or any challenges maybe that you encountered?
Yes, I can. It'll be a little bit remiss of me to point out that we're still in the stages of determining what the exact requirements are. But if I was a gambling man, I would say that the technology that we're using for inspecting the mooring chains, but at the moment we use ROVs, a little underwater submarine with cameras and stuff, and little arms that can measure the chains and stuff like that. But we deploy them from the big boat, the FPSO itself. So the modification of that technology, first of all, will be to deploy from a small boat, because as wind farms there's a lot of very similar assets. And that we can't have a big boat, it will be a small boat. And then the next stage, which we're working on now, is to have the ROV deployed completely remotely. So the boat it comes off will be a radio-controlled boat, a big model boat, and the ROV will be a remote-controlled ROV. So we'll be, like we are today, sitting in an office, controlling the inspection of a critical part of the systems, but not even having to go near them. And that's where we're heading, one of our first innovations.
Now, as the renewables industry continues to grow and advance with lots more players becoming involved, what other innovations are you working on? I know you mentioned the remotely operated vehicle without people. Are there other innovations for the wind energy sector you are working on?
We're gathering together a group of clever people to help us do this thinking within the JIP. And the things that seem to be an issue are the fact that these floating wind farms are connected by cables, and therefore those cables are very, very important to the continued efficiency. So we're looking now at how do you assure the integrity of the interconnecting cables. That's a pretty big issue. And the other thing we're looking at with another organisation based in Europe, a big organisation, is what do we do about the blades? Now these blades are massive structures and they're moving. So I suppose one concept, which is not totally disruptive, is to stop them moving and then either put a robot to climb up and down or have people climbing up and down. So another technology that we believe we can develop is, can we inspect these blades while they're moving? And I think that's possible with some of the advanced synchronous laser methods that we learned elsewhere. So we think that could be an important area too.
It sounds like you do a lot of sharing of knowledge between organisations. Do you think that's really important to improve and develop what you're doing by putting more brains together?
I think it's absolutely crucial. I think any organisation in today's world that think it has all the answers isn't going to survive long.